Hello, everybody. My name is Marty, and thank you for coming tonight. This presentation is called Stop Coding Like a Moron. I originally approached the group at doing this talk a few weeks back. I'm going to talk for a minute because I'm waiting for confirmation that everybody can actually hear me. Basically, I am a very big fan of people using best practices and making code that's easy to read, it's easy to understand, you can glance at it, and you really understand what's happening just looking at it for a few seconds. So, what we're going to do is look at some code in React, which I took from a very popular library, Redux, and we're going to look at how they gave example code for how to use Redux, and we're slowly going to refactor to something that I think is in a much, much better form. Now, if you haven't used React before, you really don't need to worry about that. I'm going to explain all the Reacty stuff happening. You really just need an understanding of JavaScript in order to follow. Now, a little bit about me. I'm a recent graduate of General Assembly Software Engineering Immersive Remote Program. I started in February, I finished in May, and I've been working on changing my career since about this time last year. Um, Currently, I'm a front-end engineer with Crocodile Labs, crocodilelabs.io, if anyone wants to check it out. The website is not very good, but we do have a new one. We're just waiting for it to go live. But that's my company I work for. I was employee number two. And we're building a new cryptocurrency exchange platform. And now, let's see. Oh, yeah. And I already talked about that. We're going to talk tonight about how to write code that's easy to read, understand, maintain, and test. Now, why write good code? Let's go through a few boilerplate reasons. Anyone can write code that works. And just because it works and works effectively, maximized for space considerations, that doesn't necessarily mean it's good code. Your code, yes, it exists to process data. I'm also going to say your code exists to get you a job, to make your company money, to be useful to other developers, etc. And if that's a concern for you, this is a good presentation. It needs to be understandable by other people than you. If your code works, but someone looks at your repo and can't understand it, you're not going to get interest from that recruiter. Your code needs to be understandable by you too. If you haven't had an experience yet where you open code that you wrote on a Friday afternoon, on a Monday morning, and you can't figure out what you were doing or how you made it work, you're going to get there sooner or later. The better you write your code, the more self-documenting it becomes. Your code needs to be maintained by people other than you. I've seen various numbers, but figure that a lot of developers spend less than a year in a job. More often, if it's their first job and they need to just get past that hump of having their first job to move on to their second, which will probably, in many cases, be a lot more interesting, pay a lot better, etc. There's a big bottleneck for developers at the true entry level. So, of course, a lot of people take their first job and move on, but I think you have a responsibility to leave code that other people can use later and aren't cursing your name every time they try to understand. And I'm also a believer that it's better to spend more time now and have less tech debt. If you invest a little bit more time now in refactoring your code as you write it so it's better, you will save yourself and your organization time later when you return to it. And more simply, we're going to start with some code and we're going to refactor it. And you tell me at the end if you think the before or after is better code. And if we have some extra time, we're going to practice a little bit of live coding, pseudocoding as well. So let's keep moving. The first concept I want to talk about is use your monitor's full dimensions. Now, by the way, I did a lot of work to make the code as big as possible in the screen. If you're watching on a small screen, this is being recorded. You might want to revisit later on a smart TV or a larger screen where you can read this a little bit better, but I'll run through it if you have trouble seeing. Now, a lot of people have a big monitor, but they're afraid to use the full real estate of the monitor. I'll talk a little bit about that in the next slide too. Don't just use the vertical size of your monitor. Use the horizontal size too. Now, this is an image of tutorial code from React Redux. If you know React, read through this and just kind of get a sense of what does it do? What does it render? Now, for those of you who don't know React, what I want to tell you is basically all React does is it takes HTML or a form of HTML called JSX, which is basically HTML for all intents and purposes here, with a few different words, such as it uses class name instead of class. And what it does is it plugs data, into templates. So if you go to CNN or Fox News or NBC News and you see 20 articles on the front page and they all have a similar format, that's basically the same. We call it a React component, repeated 20 times, and it just plugs different data into each iteration of that component. So basically up here, we have some import statements that are bringing in all of our dependencies, bringing in React, bringing in other dependencies working with it. And here we have a function. This is the function that's generating our DOM, the HTML website that we see. And what it's doing is it's generating two buttons. It's generating a value here called count. Here's the second button. And three buttons are a minus, a count, and a plus. Redux, which is this is sample code for building the classic Redux sample app. Redux basically helps manage state, and I'm not going to get into what it does special, but it helps you manage state. And this is the classic Redux sample app, which is basically a counter. There's two buttons, minus and plus. There's a number in the middle, and when you hit minus or plus, the number in the middle goes up by one or down by one, depending. Now, there are a bunch of things I want you to just think about and take out, but overall general impressions. Can you look at this and within 10 or 15 seconds tell what's going on? Not easily, in my opinion. So let's keep moving. Now, I said use the full real estate of your monitor, and I meant it. This is a screenshot of my full IDE. My monitor is obviously organized horizontal. This code is organized vertical. Now, there are a few, and the biggest one is you're not the only person looking at your code. I have a 27-inch monitor, well, a pair of them, but you do need to consider that your code might be forked by or looked at a recruiter or a coworker using a smaller monitor. So you don't necessarily want to take your code all the way to the end. And I believe you can see my mouse, but if you can't, I apologize. You don't want to take your code all the way to the end, but frankly, you're wasting a lot of space. And this is also very hard in very long files. Like if you ever do something with MVC architecture, which is the classic architecture for MenStack back end apps, you end up with maybe 300 lines of code because of all your controller functions have to be in one file normally. And when you're doing full CRUD in one file, it adds up to a lot of different functions quickly. So you want to try to use, when possible, the horizontal space to better organize your code. Let's go forward a bit. Now here, this is my first refactoring of this code. What did I do? In fact, all I did was remove some line breaks. First of all, these here, line 3, each of these items, decrement, increment, increment by route, increment, async, and select count, they were on previous lines. I put them on one line. They were on previous lines to make them a little more readable, but personally, I think that this is perfectly readable to me. If I was typing this code, I know what I've imported, and it doesn't help me that much to break them up onto second lines. Secondly, down here, my buttons, the opening tag, I move the entire opening tag onto one line. Now, I will say this gets a little busy going across. Two comments. One, I use this on the computer I don't usually code on because that's the computer that has PowerPoint on it. So I didn't have my preferred IDE color scheme. I normally use Atom, which helps. And secondly, we're going to improve this even more later. But first of all, I think that in the return statement, first of all, it's not as long, but also it's easier to follow what's going on now. Opening tag, content, closing tag, opening tag, content, closing tag. To me, this is a much better organizational scheme. I think that's all the things that I have here. So let's go to the next slide. Oh yeah, fewer line breaks. Doesn't this feel better already? And for reference, this is the same thing we just saw. However, I'm showing you it in my full IDE screen so you can get a better sense of how it's spread throughout the page. At a glance, I feel that for most people, this should be a lot more readable as you go through. Now let's talk about that ugly return statement. It's really, for me, a red flag when the return statement is 90% of the vertical real estate of your function, and you're going to see that improve in the next couple slides. Now, think of a function of having two parts. What does it do? What does it return? What does it return is simple. That was the return statement. What does it do is everything before the return statement. Always simplify your return so you can glance at it and quickly see, exactly what it's outputting. You don't want to do calculations in your return. You don't want to do this or that in your return. You want to either put in a single variable or you want to put in structure with multiple variables, and you'll have a much more readable product. And what did I do here? The main thing I did, actually the only thing I did, those two buttons, I took each of them out and I stored each button in a variable. Now, if this was vanilla JavaScript, again, I said that this wouldn't be a React lecture, even though I did it in React. If this was JavaScript, the only difference was these would be stored as strings, not as HTML. Basically, again, it's JSX, not HTML, but for all intents and purposes, just think of it as slightly different HTML that can be read by React. And then I put in each one as a variable. That's all I did there. But here's the big thing. Even though I didn't save a lot of space in the return, div, nested div, increment button, span, decrement button. This is much faster to read and quickly see what exactly is this function returning. Now, I want you to start looking at what's the absolute worst thing on this slide that we might be improving next. For me, the absolute worst thing here is simple. It's these long lines here, 10 and 11. Now, I think it's an improvement, but I think that we can still do better. Now, like I said, our return statement only contains structure, not things. And now let's do something about those button elements. Now, here's the key. If you need it more than once, generate it. This is a key with any kind of templating, especially with React. Some things need to be hard-coded for one reason or another. If there was only one button, there's no point in generating the button because you only need one of them. But maybe you need to think twice. Maybe you're using a framework, that doesn't allow template generation. I was building a new website last week in Gatsby, which is a framework for React that takes care of a lot of stuff for you. And it turns out there are sometimes that when you make a template literal, you can't inject values into it, which I was surprised by and took a little while to troubleshoot. But once in a while, you just can't generate templates for one reason or another. Anytime you use a thing twice or use two different things that have a very similar form, try to generate it instead of hard coding it. And bonus points if you can employ .map or other relevant higher order functions in that process. Anytime you use higher order functions, your code becomes more self-documenting because you're moving a little closer to your code reading like a sentence. If you need it more than once, generate it. So what did we do here? There are two changes, well, actually three. First, I want to point out something important. I'll jump ahead. Remember that there was a span here that had a count. I took it out temporarily. I'll put it back in at the end. The reason I took it out because when I insert two buttons like this, I can't easily put the span in the middle. This isn't a shortcoming of React or this approach. It's a shortcoming of how the original code I started with was set up. I would have set it up differently from the start so I didn't have that issue, and you'll see I'll put that span back in towards the end. But so there's two things I did here. You may remember those two lines with buttons looked almost identical when I had them lined up vertically. All the characters lined up because everything was the exact same number of characters between the two lines, even though a few of the values were slightly different. So what I did here was I found the three things that varied between those two buttons, which was the aria. ARIA is basically a value that if you have a visually impaired user using a screen reader, the ARIA will be what their screen reader tells them the thing is. The dispatch function, which for our purposes, just think of it as a callback function. It is what it does. It is not important, but it's a callback function that attaches functionality to that button so that button does something. And the actual text of the button itself. One button had text of a plus, one button had text of a minus. So what I did, I set up basically a mini store. This is just an array with two objects in it. Each object tells us what are those three values that differed between the two buttons. And then down here I have a template, whoops, sorry. Down here I have a template generation function. Const buttons uh, is going to be our new variable. And what it does is it gets buttons data, this array here, and it maps over it. For each element, it's going to take the element button and it's going to return the data in this format. And this format is very simply the same structure of that button previously. Let me go back and you'll see here's a button, and these two buttons differ in three places. They differ in the ARIA label value, they differ in the callback, and they differ in the text. So here, ARIA label, I'm plugging in the value ARIA label. On click, I'm plugging in the dispatch function. And for the text between the opening and closing tags, I plug in the text. So this is going to generate those two buttons, and I insert them right here. Now, we're going to keep optimizing this. If you're thinking that this doesn't look great yet, we're going to make it better. However, you should be seeing now that this is a little bit simpler to follow the story of how are we getting from that data to creating a template. Our function itself is taking up more of the space. Our return is being simplified. This return is nice and simple. We have a div. There's a nested div. We would put anything else we want here. And inside the inner div, we're generating those two buttons and rendering them. Now, again, I said previously, look at each of these slides and think, what's the absolute worst thing here and how can we improve it? Well, first, I talked previously about using horizontal real estate and not aligning everything vertically. So let's fix up these two objects here. Only change I made here was that instead of having each value on its own line, I put them all on their same lines. Objects do not need line breaks. The line breaks are just to make it more readable. But again, here's a secret. Anytime stuff is arranged vertically so it lines up, it still remains readable. ARIA label, increment value, dispatch function, text, this. In my mind, these are very easy to compare visually and see what they each are. Now, if decrement value was a much longer string and maybe the function was not the same number of characters and these were grossly different and you just couldn't line up the values like you could here, sure, leave it like this. But in this case you can, so I'm saving some vertical real estate by putting everything on one line, and I think it's still pretty readable. Now, the return statement is the same. All of this stuff up here is the same. So again, let's play that previous game that I said. What's the worst thing on the screen and how can we possibly improve it? For me, the most visually complicated part that we have now is this button right here. This is just getting very, very long. I don't really like the structure of it. But pop quiz. How do we optimize this very specifically for React? If anyone here does know React, you should see pretty quickly. If not, we'll go to the next screen. And that, very simply, is to use a template or a component. Now, for those of you who don't use React, keep in mind what I said previously. You're generating multiple similar things with the same template, just feeding each uh, iteration of the template with different data. And that's what we're doing here. I'm not going to show the exact text of this button, but basically it's a function that produces this here. It's going to plug in the values the same way, but instead of having this callback function here, I'm taking this function, I'm putting it in its own file, and I'm going to call it here once for everything in this array right here. Const buttons data dot math. This is exactly the same. All I did was I changed the callback function to, instead of producing a button each time, it's rendering a component, and that component has that structure internally. And the return statement is the same too. Next, we're going to talk about sectioning your code. Now, some of you may be really old school coders. I'm guessing a lot of you are probably newer. In my case, I'm a newer developer, but I did take one computer science course back in college in 2004 or thereabouts, and that was compared. It was definitely modern coding, but it was still the dark ages compared to what we have today. And I actually first learned to code using C++ and a literal text editor. Now, there are some people who say that things like VS Code aren't really properly IDEs, they're text editors because they're more pared down function. If you have ever coded in a notepad file with black text on a white background, you will call VS Code, even though it's slim, an IDE. I would call anything that changes the colors for me an IDE, and it makes it so much simpler compared to what we used to have. But back in the day when we didn't have things like pretty color schemes um, or linters, you would have to really use commenting, not just to explain your code, but to also section it up so you could easily find different sections of it as you were scrolling through manually. So I took the same principle here and I sectioned up import statements. Let's go back a little bit. And I just have 4 lines of imports. Now, imports can get very crowded very, very quickly. And it can get visually hard to go through and look for the import statement that you need to find if you need to adjust one or if you need to add more, finding a place that makes sense. What I do, I have comment tags for starting a section of imports and ending a section of imports. My first is import React and various dongles associated with React. Some will be from React, some might be from React frameworks like React Redux, et cetera, et cetera. And then import local files. This is where I import style sheets. I'll import if I'm really sectioning up my React data for React developers and hooks are in their own file and there's templates in their own files and I have stuff really separated out, my local file imports will be here. If this is getting more complicated, I might even break it up for importing style sheets versus importing images, importing this, importing that, etc., etc. But basically, I just use these comments to section off my imports so I know what's where. Now, this applies in other kinds of tech stacks too. It's very valuable, in my opinion, in men stacks. Uh, Men stacks, a lot of your files end up really, really complicated vertically. And if you're looking for your gets, your posts, etc., you can easily scroll through and find the notes that say this is where your gets start and this is where your gets stop. And it really helps keep things organized visually. So that's the one thing I changed here. And I think that this makes it a lot more readable too. And it makes it even more readable once you start doing it all the time and you get used to your own format that you use in every single file. And that's it. This is something that I would consider in mature form, reformatted exactly the way that I personally like it. Now, first of all, let's look at the organization. I find this a much more visually pleasing and easier to read section of code on the right than this on the left. Personally, my opinion is always that code should read like sentences. When you get really good at coding, you can actually look at this and read it as sentences. The constant variable count gets The return value from the function useSelector fed in the argument selectCount. The variable buttons data gets an array with two values. Those values are objects. Const buttons, etc., etc. You get the point. This I feel like I can read as a sentence. Whereas on the left, they truly put one thing on each line, which isn't bad separation of concerns. I'm not going to complain about it too much. But I prefer, rather than one thing in the strictest sense on one line, one group of things that make sense on one line. One-liners, as long as they don't get too busy, are always a lot easier to read. Now, next, how many lines did we take up? This goes from 1 to 38, so it's 38 lines. Over here, 1 to 30. So first of all, we have fewer lines of code on the right. But on top of that, we don't just have fewer lines of code. Imagine that this was a much, much larger file, like again, those menstack files that might be 200 lines of code per file. You're going to have a much easier time scrolling up and down trying to find the one damn thing that you're trying to find and you don't know where it is. You kind of remember, but you're getting so frustrated you just keep scrolling back and forth past it. As much as you can reduce how many lines of code you're using, you're going to make your code more readable. Now, also, and I did put back in the span that I took out previously. I remember it said insert more content here. I just threw an H1 that said let's count just so that I could get rid of that ugly thing, but still be fair about how much code I actually had in my total code base for this file. Now, another thing is, you might say that's a lot of work to reduce it from 38 lines to 30 lines. On the left versus right, take a moment and actually count how many lines of code are there. On the left, there's really only two lines that are actually blank. Whereas on the right, I have 5 blank lines. Blank lines are white space. They make it easier to read. If you ever have gone on message boards and see someone who makes a big post and they're allergic to line breaks, you probably haven't read it because it's a wall of text. Breaking it up on the right makes something that's more visually appealing easier for the eyes to parse. And on top of that, it's not just more blank lines. I added in 4 comment lines to section things off that really aren't code, they're just visual organizers. So actually, I reduced this by another 9 lines on top of that. So this actually really isn't a 30-line file. It's actually a 21-line file if you're really doing an apples to apples comparison on how many lines of code I reduced it by. In other words, on the right is almost half the size as on the left. Again, I resized some of these pictures, so if you're saying it looks all, I was trying to make them as big as I possibly could because I want to make sure people can read them. This, if you look at them next to each other true size, this is way smaller. And again, all those little things are going to make it way more readable for you. And that is the end of that presentation. So I have a few more minutes left, so we're going to do some quick pseudocoding as well. And let's just open up code.js. Oops, excuse me. Of course, I do stupid things when people are watching. Now, the other thing is you're not always refactoring code to make it better. Although I suggest anytime you're writing code, refactor as you go to make it more readable. Sometimes it's easier to type something, especially the callback in those higher order functions. It's easier to type it up over multiple lines. But then I like to, after I've typed it, take out the line breaks and make it into a one-liner because then it's going to be easier to read and it's going to be easier to keep more stuff on the screen at the same time. Now, the big thing that I want you to always think about is a lot of people, frankly, are very bad at writing code when they start with a blank file, and that's how you get a mess. So let's talk about something. Let's talk about, I was actually thinking about this, and I think that a great way to explain it is with card games. So I'm going to take this for about 5 minutes until we see the general pattern. Well, let's say that we're programming a card game, and we're specifically programming war. And let me zoom in a bit too so people can see that a bit better. Or actually, no, let's do hearts. Now, for anyone who's not familiar with hearts, it's rather simple. 4 players, each one has 13 cards. Someone goes first. Let's say that they throw out the suit hearts. If they throw a heart and you have a heart, you have to throw a heart too. The person who has the highest card of that suit takes all 4 cards, and they start the next round any card that they want. They don't need to stick with the same suit. That's the basic flow of the game as far as we need to know. So how would we approach this functionally if we wanted to program a game that's hearts? What I've told people a lot is you need to break out of the thought of writing code and think of the process of how does it work. First, I want to create const state and in a single JavaScript file. This is fine. So let's just throw that there. And now we're going to do functional programming. Let's just go through it first steps. What's the very first thing you do when you start a game of cards? You shuffle the deck. Function, shuffle deck. Now, I'm not going to code this function. I'm going to ask, what do we need? Well, first we need the deck of cards. So in state, we're going to do, let's see, let's do deck, and a deck of cards is going to be best represented by an array. So let's just leave that there. Okay, after we shuffle the deck, what comes next? Well, now we have the deck shuffled. And you know what? We may want to do a second game, so we may want that original deck just as reference. So let's, instead of reassigning the value deck, let's make shuffled deck. Now, I'm going to set it to an empty array because when this program initializes, there won't be anything there, but we'll put something there. So function shuffle deck, it'll do stuff. I'm not going to worry about exactly how I accomplish shuffling the deck now, but it'll return. It'll return actually I should const output, and const output is going to get whatever the production of do stuff is, return output. This is another important thing. I am not doing return then my calculation. I am making it happen then returning whatever I produce. But now we have a shuffled deck. Great. What's the next thing you do in cards? Well, you're going to start dealing them out, right? You deal, there's always 4 players in hearts, so you deal 1, 2, 3, 4. 1, 2, 3, 4. Let's do function deal cards to players. Okay, so what exactly are we going to do here? Let's think this out. Well, there's a couple ways we could do it. First of all, we have 4 players, so we're going to need everybody's hands. So P1 hand, comma, P2 hand, comma, P3 hand, P4 hand. Now, I have a few choices. I can either have the function return something, or I can have the function do something. Not all functions need to actually return something if you build the functionality and reassignment into it. So let's think about that. Well, first we need to deal a card to player 1. Okay. Deal card to player 1. And obviously we'll need that function down here. We're not going to actually write out right now, but let's just create it so we know we need to later. Now we're going to need to deal a card to player 2. So same thing, let's create that function too. So we remember to create it later. Oh, but here's the thing. Remember I said anytime you see something happening twice, you have the possibility of automating it? We have the ability to do that. Now think about this. Am I going to have deal card to player 1, deal card to player 2, to player 3, to player 4? Do I really need 4 functions for that? We saw in the previous lecture I just gave that when we had 2 buttons, we just made a data bank and we generated buttons from that data bank. Dealing cards to players is basically the same thing, no matter which player they are. So we can take that same principle we saw previously and apply it here in a rather different situation. I'm going to show you this. Take out this. Deal card to player. Let's just do function deal card to player. Very important. Multiple, singular, not same function. P1. Excuse me. So instead of having to do 4 functions to do the same thing in 4 slightly different ways, we're going to take the same function and we're going to simply hard code in a different value each time. So the point I wanted to make here is we can actually take the same principles of don't keep specifying everything you need to do explicitly. Find ways to automate things and reuse generation functions. It is all over the place once you start looking for that and become obsessed with optimizing your code for simplicity. Here, I just turned 4 functions into 1 function by simply putting in arguments to the function that I'm calling and calling it again and again. If you want to get even simpler, you could do this as a loop. We could do, and my linter will probably yell at me because I'm going quickly, but for let I get 0, I is less than 4, I plus plus, and then here code, or I'll actually put it in that, and I don't want to actually type it, but do PI so that we have player 0, player 1, player 2, player 4. I don't want to get into actually fixing it so it works like that, but you get the point. Now I've reduced it to 1 line instead of calling this 4 times. It can even get simpler. Say that this, or more flexible. Say that Hearts was a game that you could play with 3 players, or 5 players, or 6 players. I could actually up in state hold number of players. And then down here, this could get number of players. So now if I want to reprogram the game to have a different number of players, all I need to do as a developer is change the number in state, and this adjusts. So that's the big thing I like talking about. Write your code, but always look for how can I make this simpler? How can I make it easier to read? How can I automate it so that I start with data and then have fun, functional declarative programming that does stuff for me rather than hard coding everything. If you work on that, you're going to have a much easier time reading your code and understanding and explaining it to other people, and other people are going to thank you for it. Um, I think that that has been a very good talk. It's been a pleasure being here. I just got a text, so I think that our moderator, if I check my phone, has texted me. Actually, oh, nope, completely unrelated. Apologize for that, but thank you very much. And if you have any questions, he will pass them on to me.